Okay. Thanks a lot for the invitations. I tried to put some questions mostly in this presentation. So this is a question not mostly to present results, but to present questions. So I hope it will end at the end at some question. So the main question is how we restitute, recover the appearance of ancient objects from what we have to what we can see in the ancient time. So I've taken this example. This is an ongoing project called Adelph 3D with all these partners. And this is the first restitution that have been done. And unfortunately, I have to say that now this has been done manually using 3D tools, 3D relief, and so on, and only validated by the expertise of Benoît, his name in the last presentation, despite the fact that there was an intensive documentation, archaeometric documentation with physical, chemical analysis, composition of the different walls, parts, with XRF, Raman, and hyperspectral imaging also. So based on this fact, now I will go a bit on what is currently in use for cultural heritage from the 3D world. So why there is such a limitation currently, even if we have a lot of archaeometric data to restitute what was the previous appearance. The first of all, of course, we can simulate everything, can compute everything, but for each new parameters that we want to tune to check an hypothesis, it will be highly resource demanding, and we need intensive simulations. So we can do some measurements, but this is only for the current appearance. We need to have the possibility of de-aging or to test the different hypotheses. And this is a very high dimension problem to capture all the appearance. And unfortunately, currently in the use of appearance acquisition for the 3D restitution is always limited to edge color, not spectral, for basically due to limitation in the acquisition times to be compatible with all the 3D rendering tools and so on. So to come back to the dimensionality of the problem, what if we want to capture the wall appearance? This is a 12D, 14D, we can see in the literature also dimension of the problems. I put it as the two references from which I've taken this taxonomy. We can't reduce the dimension by removing the time dependency and to forget the wavelength dependency. We can reduce again the dimension by removing all the subsurface scattering effects. This is very, very highly intensive computation. We can still reduce the dimension by removing all the spatial variations, or by simply removing all the directional components, having simply what is the diffusion inside the object. And at the end, we can still remove some animation to have what is currently mostly used: reflectance property, diffuse property, albedo, texture, and so on. Color texture, spectral texture, sometimes. And I'm adding a new component in this taxonomy. This is called the reflectance transform imaging. This is the mostly used technique currently for the restitution of 3D cultural heritage. And I will come back to it a bit later. And the first appearance measurement that was really done in 3D for the cultural heritage was a bidirectional texture function. I will come back a bit later. And more recently, some spatial varying here at the end. So the main idea, if we look at this dimension, we want to acquire everything so we can observe the object better as we were in front of the object. So based on this hypothesis, there was a project named Materials between these partners that have developed this robot in order to do the acquisition, 3D acquisition, and all the rest will be the acquisition. And it results in a lot of data that are hardly manageable, hardly visualizable. So this is another question of why there is such a limitation. So I was talking about the BTF acquisition that was in the same dimension. It's simply a surface view from different viewpoints in different lighting. It's different for the BRDF because it contains all the shadowing, all the anti-reflections that can occur on the surface. It's not a characteristic of the material, it's a characteristic on the surface. And it was used for occurrence I've seen in the use of 3D for petrol heritage. It was 2011 by the persons that have developed a lot of techniques in the Bonn University using this dome of camera to capture everything. But there is some limitation for the BTF. BTF is not good for characterizing the appearance of the object because it's a surface, but also what's again, what I say, all the shadows, all the anti-reflection, and so on. And so it's suited for the visual reproduction, visual restitution, but for the not visual analysis of an object. So what I've said is that the technique that is mostly used currently in the domain of petrolage is a reflectance transform imaging that is coming from a paper, old paper now, published in 2001, named Polynomial Texture Map, in which you acquire the appearance of the surface from one given directions, but from multiple light directions. And in order to reduce the size of data sets, we do a polynomial approximation of this data. It has been improved to use a better polynomial function that hemispherical harmonics for higher contrasts and better specularities. And it has been a lot developed to be able to be used on-site for on-site acquisition using either some dome that you can carry on-site, like I've shown these two examples. But mostly used techniques was to use a reflective sphere in order to detect where the light is coming from, kind of calibrate what is the direction of the light, assuming that the light is coming from an infinite distance. It's directional light, not ultralight. And you can see on the right the condition on which people had used such a technique. So the accuracy is pretty low in such a basis. Mostly what we get at the end, thanks to this reflectance transform imaging, is what we see from the given points. And by using some differential analysis, we can try to estimate the normal of the surface. This is a very good technique for the visualization, but the normal estimation is quite rough due to the lack of precision if we have not well calibrated all the system for the acquisition. Currently, there is a new trend for better normal estimation called the stereo photometry, in which we can, with a well-calibrated procedure, about the same thing that the reflectance transform imaging, that is capturing what we see for an object with different light sources and assuming a diffuse albedo, we can try to recover the normal from this different lighting. So we see paper from this year in the Journal of Cultural Heritage. And this has been used to recover some normal map from different artifacts, and also in caves, because we don't need a lot of tools to carry in caves to recover some maps. On our side, we are trying to recover some appearance of large buildings and setting on large buildings. A point here, I will not discuss all the detail here, but simply to the conclusion, we have done an intensive survey based on the blueprints, water color, what we have, some real color photographs from the 19th century and some from all sorts of glass, 3D scans, and so on to create this kind of restitution. And what our goal was to have a good restitution, but a saving. So this is a kind of result that we have obtained. So on your left, you have the actual photographs that were taken. On the middle, what we have computed based on the our estimation of the spatial varying ELEF, and on the right, new points on the same. So it was a lot of work, a lot of data, and perhaps it was not necessary because once we had studied and we stay a lot in time of one of the objects, we are sure that this is not the actual painting. The actual painting is not the painting that we have when such a photograph have been taken. So even if you are doing highly precise acquisition, characterization, and so on, it's very difficult to recover what was ancient acquisition. Fortunately, we have for this object another examples that is preserved at the Victoria and Albert Museum. It was a sample that was taken for the Universal Exhibition in Paris in 1878, and that was bought by the Victoria and Albert Museum in London. And the question is, can we use this one in order to recover the correct appearance that will match this kind of black and white photograph? You have an idea of what was the reservoir appearance. And we fall back to manual work, which we have segmented the shading, create different category, a kind of palette for different painting, and try to adjust the 3D models, the 3D appearance models that are classically used for 3D rendering in order to adjust all the parameters, mostly color or at this code in the model, and more diffuse albedo, color albedo. That will be better to calculate the variation of the normal. That was very, very important compared to the recover the appearance. And from what we have obtained, we obtained such models, and it actually pretty much what we have in the black and white photographs, and with changes that I will not pleased with is that instead of the blue that we have on the Victoria and Albert Museum, we have to choose the background as a gold, and I'm pretty sure that we have to explore more the different parameters. This is one difficulty. This is a lot of tuning. Find over all the possible ELEF what was the correct one that match the black and white photographs. So this is still ongoing work, and I will come back to what we really want in order to restitute the appearance for a dark geometric point of view. And I prepared some slide and will be very similar to the previous presentation at some points. Because in order to study ancient artifacts in archaeometry, they are using a lot of mockups. Let's talk about this in the previous presentation. So mostly it's fabricated samples with known techniques, composition, and with the techniques we can have a correct historical and archaeological information. We can do a dense acquisition on these samples, and this give a reference that we can apply and compare with for other techniques. With such a technique, so this one was for gilding. This is another technique that I've seen for painted wood, polychromic wood, in which they have also used to simulate the aging, the effect of the aging on the change of the color. This is another dimension of the problem. Yes, there just was a question about this, about the presentation. And so mockups, I've seen the name of charts for about the same idea. So this was the work of in archeological Bordeaux, Hortense de la Corde, for tapestry producer, in which they try to work over what was the appearance and so on. And for this purpose, what they've done a lot of samples with different pigments and different edges, exposition time to UV in order to see what was the change of the color. And they try to, after that, restitute what was the color of the tapestry. We can find also the name of reference, so mockup, charts, reference, everything is about this. Here, something that was named a reference is a reference of a database for ceramics with non-composition and so on. So everyone that are studying ceramics can refer to this kind of database. And what is interesting is that once we have such a database, if we have new information, new measurement and so on, you can compare to the existing database and see if some archaeological or historical information are missing. Perhaps you can, by this comparison, and diffuse this kind of information to the new samples. So this is very interesting, and perhaps we can find in cryptographics some techniques that are similar to such an approach to the diffusion. And there was some, not a lot, and quite old. Sorry for the information. There was a paper from 2010 called Manifold Bootstrapping for SSE14 capture, in which they use a two-step approach to capture the full spatially varying RDF. At some precise position, the captures of the RDFs and dense measure, and after, by similarity, the process with less dense measures, they propagate these models in order to cover a full variation of the PRDF. So they can create a kind of referential and after spread this referential along with some well capture images. There was another paper that was using what they call a PRDF chart. So instead of a chart, use a PRDF chart with well-known PRDFs that we got characterized. And they acquire at the same time this PRDF chart and the samples that they want to measure. And once again, by comparison, they try to infer new PRDF models that is mostly linear combination of the PRDF that are in the PRDF chart. The idea was to have something that you can do with low-end devices. The most well-known techniques that you can refer to was the work of Manutech-SLEIGHT from their laboratory in 2003, in which they performed the acquisition of they have done the acquisition of more than 100 BRDF based on the spherical samples, mostly painted spherical samples. And what was interesting is that they, after do a very small search to the person, and they have to classify for each of the 100 BRDF, which category they classify each BRDF. And here are all the category. I've sorted them. You can see redness, more color category, redness, greenness, blueness, There are something more about the property of the BRDS, specular nest, diffuse nest, nest. Some mostly about which kind of material, metallic, plastic, gold, fabric, and so on. Some also some roughness, similarness, greasiness, dustiness, and so on. And the idea was to reduce the dimension of the problem that during the PCA analysis, non-linear principal analysis, with the dimension 15 instead of 100. And based on this classification, user classification, after we can modify existing acquisition by playing with different parameter, saying if I want to increase the wetness, we move toward the levels, the depths that are classified more using this classical analysis. And going back to metallic, they have, for example, increase for the specular gold, increase the silverness of the average. So mostly the idea behind it is that if we have a database with well-known classification and understandable classification, what we can answer to the edition. And this leads the question to what is currently a lot used domain, artificial intelligence. And I simply point to this paper because it's one of the first that I use artificial intelligence for especially it's highly cited. It's from 2019, sorry, I have integrated here. And the main problem of such approach, of such point, for just now, all the limitations for cryptographic approach that we have is that they are only visual validation. And there is no information real of what is accuracy. There is no methodology. There is a lack of perceptual studies. So we interpret pretty images that looks like what we expect, but that looks like what was the reality. They have artistic goal. Don't see all the parameters that we have for the Manutech database are mostly understandable by artists more than physically based or biological based. And there is a lot of physics that are not present in the model. And when we add the artificial intelligence about it, the validity is questionable mostly because it came from the database that we are used for training. And the papers that I just presented in order to create sufficient amount of data in the database training. They have simulated a large set of images comparable to what we can take with a cell phone with a flash, but it was a cryptographic model from the IDF. And after they do it on real cases, there's a question about the validity. So that's there. And so this is the main problem of AI for concentrating. But if I came for the conclusion of this presentation, you have seen that we are sure now that there are lack of really physically based models for building the environment. There was a European report for your project, previously, that I've done a study, which a lot of them that missing such models. For this purpose, we need to have appearance model. Mostly they are that are visually unbiased. So we don't want this like what we see, but we want to visualize, interpret without having the bias, something that is considerably realistic. What will be interesting for such a model is that we can tune the different algorithmic parameters. Take tune, for example, the aging, that is a code of all that are bits. We can change the composition for different for the bonds, the paints, technology, and so on, and see what is the real effect of the difference. If we have such a model, perhaps we can go back if we have some addiction, we can fall back to some archeological parameters. And this will require a lot of data. I mean, this is mostly the conclusion of the talk. And about the AI slides that came just previously. We need to create a link between what we acquire, what we see, and all the other information into a public databases with all these kind of information that people come refer to. They are doing some extra measures. And fortunately, we just managed to have a PhD to and we will be pleased during this PhD people want to work with to collaborate. So, thanks a lot.